sheer fascination of the tool, he really looks forward to creating his own neural network for detecting the landmarks. So he goes through a rigorous process of collecting data, labeling data, and clearing data. And it's what we just talked about, the steps of the build a machine learning models. So, and finally, he create a machine learning model that can tell him which monument it is. So everything looks really, really good now. And he's able to reach a really high accuracy score at will. Now, the only challenge that he has is where should he deploy the model that he created. So so after searching, he has two options online, and one of them is the cloud computing. And he takes his trained model and he deployed it on the cloud. He exposed the API that he's created, and essentially he created an Android application that kind of will query the API that and fetch the result of his application. And once he passed an image to his application. And now one of the major challenge that he saw when he created the solution is the latency because of the cloud computing. So why? The image that's captured generally by cell phones today will range between 3 to 10 megabytes. So this time, transporting such huge files really takes up a lot of time in the entire process of making the prediction. And the second piece is that we add the complexity to the entire solution is the cost. The neural network that June has created requires the resource, a storage resource we can save the model's weight, and a computer resource for making an interface. So what he does do next is he create an Android application, and he find a way to make an interface on the Android using this huge model that he's created. So Juan now face a new issue. The issue is the model is too huge, and the cell phone is not really capable enough for storing and processing such big model. So now Juan is really confused. He tried out different techniques to make his work, and this time TensorFlow Lite comes into picture. And before we jump or discuss about the TensorFlow Lite, I want to introduce what is the edge device. So an edge device is defined as any piece of hardware that controls data flow at the boundaries between two networks. So imagine you are in another plant and you need to communicate with another plant, and then you can ask yourself how you could access the data from outside. So this time an edge device is a network component responsible for connecting your local area network to an external or the wider area of the network, where you can collect data from everywhere. So think of the smart devices you use, like the tablet, the cell phone, or you can use to connect the network. Or given how recently the device, you will essentially have increased the computation power by using more or faster CPU. You can also put your wearable device, such as your smartwatches, into the edge computing bracket. So now let me go forward and give you a formal definition of the edge computing. And edge computing, the definition of the edge computing is the practice of moving compute and storage resources closer to the location at where it is needed. So that is where your edge devices into picture. You can record it. And Juan has two options, right, to deploy his model. The first option was to deploy the model on the cloud. Now, many of you would have the impression that the machine learning model running on the server using a large CPU, which is much better compared to running on the device itself. So, which the truth is that the edge device has becoming an important platform for machine learning. And so why it gains so much popularity that we essentially have to run our entire machine learning models on the edge devices. So the first reason is because of the latency, and the use case that requires times and speed definitely requires model to run on the device. So the second reason why we creating the
Roshan, sorry, you're muted.
yeah. So how long have I muted?
What?
So how long
Wasn't
have
that
I
long?
muted?
Wasn't that long?
Or or so sorry for that. I don't know. Recently. So the second reason why we're creating the machine learning model on edge device is because of the network connectivity. And so if you go back to earlier example, where is Juan wanted to create his own version of the Google Lens for detecting the landmarks, and if he happens to visit a country where is little or no connectivity, is here to creating a model that says a device would be much more better as compared to deploying on the server, because this is an additional dependency on the network that come into picture. So the third reason is it's very important for you to create an ML model is run an edge device is the user privacy. So machine learning on the cloud means your system might have sent the user over networks, making it really encrypted. So cloud computing also means we're storing the data of many users in the same place or location, which means the data branches can affect many people at once. So it becomes really important to create such models that can run on edge devices where can preserve the user privacy data. So after all, what is TensorFlow Lite? The TensorFlow Lite is a Google's open source machine learning framework, and it's a production-ready cross-platform framework for you to deploy the machine learning model on mobile devices or on the embedded systems. So TensorFlow Lite can be deployed on Android, iOS, Linux, or other platforms used in edge computing. So, and also increasingly now, more than 4 billion mobile devices globally have now deployed the TensorFlow Lite into production. And across many different apps, many of Google's own large apps are using that. And are large numbers of apps from the external companies, and also like the Google Photos, Gboard, YouTube, and the assistants, along with some third parties like the Uber. For example, if we take the Airbnb as an example, and it's a leading service company which give the guest experience. It can improve the guest experience by using the TensorFlow to classify the images and detect the objects as sales. So what it does is it takes an image as an input, and automatically the model will classify it as a bedroom or a washroom or a hall or balcony. And also, developers are using TensorFlow Lite for use case around the image, text, and now a lot of them are emerging use case around the audio or some content generation. And so to a better understanding of our landmark detection, we need to go through a little bit about the image processing. So first of all, what is an image? And an, an image is represented by its dimensions for its height and width based on the number of pixels. And as what is pixels, we talked about in the section 2, is the smallest addressable element we can that could build the image view. So for example, here we have a dimension of the image of 500 times 400 for the width and height. So the total number of pixels is 200,000, and you just time it. And there are three terms or the glossaries you need to know about an image. So first, the first is a grayscale. So it's an integer with the number between 0 to 255, and to represent the color. And the RGB is represented by its red, green, and blue. It's made up three integers between 0 to 255. But for RGBA, is we just add the opacity of the image for the last integer, right? And so for the image processing, is a computer technology that we applied to image that can help us process, analyze, or extract the useful information from them. So the important part is we make it into digital form, and we need to extract the useful information. And also there are 5 main types of the image processing. First one is the visualization, and we through the visualization we can find objects that are not visible in the image. And next one is recognition, and we can distinguish or detect objects in the image, is what we used in our session. And next one is the sharpening and restoration, and it can create an enhanced image from the original image. And there is the pattern recognition, and we can use the pattern recognition to measure the various patterns around the object in the image. And the last one is the retrieval. Is we browse and search image from a large database of the digital images that are similar to the original image. So after knowing all the basic terms, and let's start our project. And I will pass my session to Anne to let you to import the model.
Okay, thank you, Rujin. Okay. So you can download the model. There's a link in the cheat sheet. So it's right here. Just go here and you can make sure you download the TF version. So you scroll down here, and there's the TF version and the TF Lite version. We'll be using TF Lite version. This is a pre-trained model. So lucky for us, we don't have to train anything. We just download this. Now, me being prepared, I've already downloaded this, but you can just download it right now. And it's just going to take a while depending on your connection. But okay, I'll just show you how to import into Android Studio first. Okay, so you're going to go to App, and you're going to right click, you're going to make a new. Scroll down to Other, and you go to TensorFlow Lite model. Okay, so once you've downloaded the model, you can just select it in this file explorer. Select, and once you've selected that, you can just go next, and then you can just create the TensorFlight model. But since I've already done it, it's pretty straightforward. I don't think it needs much explanation. Just go through the steps here. Once you've done, once you've imported the model, it's going to look something like this. So it's going to be an ML folder right here, and this is your the TF Lite model you just imported. And if you double click, you can actually see the notes and the description for the model. So this is the name, the tensors, the inputs and outputs, and this is really important because if you want your predictions to be working properly, you have to be attentive to the inputs and the outputs, and there's the sample code. There's even the sample code for you to implement. What we'll be doing today is just the same steps, but we have to have a few extra steps to pre-process the image, because our image is in a different input type. So as you can see in the documentation, it actually says the format that it accepts. So you have to follow these formats. So it has to be UINTA, the bitmap. And then it has to be 321 pixels by 321 pixels and 3 channels per pixels. That's for red, green, and blue for the image. So it's going to be 3 values between 0 and 255 for each pixel. That determines the red, green, and blue values. Okay, so without further ado, let's go and let's go right into it. Okay. So where we left off, okay, you're gonna go to the onActivityResult method where we display our image, and here we're just going to copy this code block right here, and we're just going to make a new method. And showing an error right now because I haven't actually declared the method, but that's what we're going to do right now. So make a new method called predict landmark, private void predict landmark, and it's going to take a URI and within the URI image, I guess. Okay. So let's just paste the code that we just copied. So it's basically doing the same thing, but we're just moving it into a method, a new method. So right now it's still doing the same thing, and we're going to add, oh, I forgot to tell you, you also need to implement some TensorFlow Lite implementations. You also need to import these dependencies. So it's right here, and you can find these dependencies in the cheat sheet here. So you can just copy it from there. And then you have to also set the ML model binding feature to true in the build features. Okay, so once you've done that, now you actually get to implement the machine learning. So the first step we need to do is first we need to convert the selected image URI to a bitmap. Okay, so these two lines do exactly that. So we'll just go here and we'll just change because okay. Oh, this is for the try catch. We'll settle that later, but okay, so this is, you basically just change the URI into a bitmap. So you do input stream, image stream equals to this method right here. You open the input stream, you use the selected image, and then you declare a bitmap right here. We name it bitmap just for simplicity's sake. So bitmap factory.decode stream, and you put the image stream that you just created. Okay, so the next step is we need to pre-process the image because like I said before, the model actually has a few input constraints, and we need to follow the input constraints exactly. So right now our image is not according to the constraints, so we need a image processor to pre-process the image. So first we need to build the image processor, and this code block right here actually lets you build the image processor. So image processor, you declare a new image processor, we'll name it exactly that, .builder, and then you will add a resize op. So this basically resizes the image to 321 by 321 pixels, and this cast op operation just changes it to UINT8. So our bitmap data is float32 right now, and to change it to your UI unsigned integer 8, you just add this one line, and then we'll just build the image processor. Okay, so the next step is you need to load the model. So within the documentation, uh, it's already been noted the name of the model. So you just do the exact same thing. So this is how you load the model. This is the name of the model. It's a very long name. Then we create the model. We assign it to the model variable, and we make a new instance of the model. So the next step we need to do is we need to initialize the tensor image. Okay, so the required input data type is unsigned integer 8. So that's why we need to specify it here. So it's going to be UINT8. So let's write that. So we make a new tensor image with the data type of unsigned integer 8, which depends on your model. And then we have to initialize the tensor buffer right here, and we have to also take note of the input constraints once again. So when we create this tensor buffer, we want to create it of a fixed size of a 1321321 and this is actually the tensor. It looks like 40 tensor, but since this one, okay, what a tensor is a tensor is basically like a data container. So basically, it's how you describe the pixel. Like, so for example, this one, we say like in this one image, there's a 321 by 321 pixels, and then each of those pixels is going to have 3 values for the RGB, so like red, green, and blue. So that's going to be like 3 dimensions, right? It's going to be the width, the height, as well as the RGB values. So that's for the tensor, and then the data type of unsigned integer 8. So that's according to the input constraints. So we've done that. Now we're going to load our bitmap into the tensor image that we just created. So just tensor image dot load. Just use that method. It's already a built-in method, and we pre-process the tensor image. So we've already created the image processor. Now we're using the built-in method to process the tensor image. So we're using this line. So we make a new tensor image called the process tensor image, and then you just feed the tensor image that we just created just now into the image processor, and you're good to go. And then you load the process tensor image. You load the process tensor image buffer into the tensor object, tensor buffer object, right here. So you go here, and you just load the buffer right here. Tensor buffer dot load buffer. Okay. And then you're going to create an outputs instance. So basically, your model is going to output a list of outputs with the label and the probability. So what you want to do is you want to create the outputs to store the outputs right here, and then you want to make a category list, or you name it probability, and it's going to equals to the outputs right here, and then you use the method get probability as category list. So you're going to get the probabilities as a category list. So these two are to generate the outputs. So right there, and now we have a list of categories that shows the outputs. And we're already finished using the model, so we don't want to use any more extra resources. So we'll use the model.close method to release the model resources if it's no longer used. So once we've had our output, there's no more need for the model, so we'll just close the model right there. And then right here, we'll just make a basic for iteration for loop. So what this for loop does is basically it's since your model is going to output a few, probably more than a few labels that it has predicted with its probabilities, we only want to display one, the highest probability, the highest confidence it has, the highest confidence of prediction. So basically, what it most confidently predicts the image would be. So this first we assign a float, a max value. So it starts with 0 because we're starting at 0, and then we assign an initial best predict index. So it's going to start with 0 as well. And we make a for loop to iterate through the outputs. So we have this list of categories. We just use whenever I is less than 0, I is less than the whole probability list, which means we haven't gone through all the probabilities yet. And then we iterate to the next iteration. And then for each of the iteration, it's going to check, there's an if statement here. It's going to check that if the current iteration is more, has higher confidence than the max value, the current max value for the iteration, then we replace that, we replace the max, there's a new max now. So the new max is going to be the current iteration, which has the highest current confidence out of all the predictions. And we also set the best predict index to what the iteration is. So this, what this whole for loop basically ends up giving us is the max confidence rate, like the prediction, the highest probability, and also the index of the highest prediction probability. Okay, so once we know that, we're we're just about done. So this is as usual, we use glide to display our image, but there's a few different lines here. So these 3 lines you'll be using, sorry, just go one by one. Okay, so this line is basically just for you, for your debugging. So in your debugger, it's going to output the highest probability as well as the value for the highest probability. So if you want to know how much probability is, you can just launch the app in debug mode, and you can just go to debug, and once you make the prediction, it's going to show you what the highest prediction is. Okay, so you're just going to set your diary location to the best prediction index. So from this probability list category, just get, and we've already gotten the best predict index from our for loop just now. So we'll just use this to get the highest prediction, and we get the label. So this line is going to display the highest prediction in the diary location. And then we request focus to so the user knows that it's actually editable if the location is wrong. So we just change this one here. Okay. So just like that. And we're almost finished because we have to check for any errors or any exceptions. So we're making a try catch block just to do just that. Okay, so this is our whole method. We make it try here. Try this and catch. Since we have since we use the input stream just now, we're going to expect an IO exception for whatever reason, and you just display whatever you want to display here. For you use directly log directory location set text, so it's going to just set at the directory location text, and you can just pass in whatever you want to display. But this is simple sentence could not predict the name of your selected image. So for if whatever reason your machine learning fails, your model fails to make a prediction, it will display this. So with that, I think that's about it. Congratulations. You're pretty much finished, and I think I'm going to show a final demo of the application. So just run app. But in the meantime, while this is loading, I'll show you how to push your complete project to GitHub. Okay, so if you haven't actually linked your Android Studio to GitHub, so you can just go to settings, and then there's a in the version control section, there's another section in GitHub, and you can just go here and you can just add your account. Now you can log in via GitHub, or since I think there are a few people that like me have some errors by logging into GitHub. So if you're one of those people that cannot log into GitHub in the regular way, you can just log in with token. So how that works is you just go to your GitHub. You can go to settings. What was the setting? I think it's settings. Wait. Wait. Where was the settings? Wait.
When you click on your profile, it's the toggle bar that you just clicked on. It's the third to the last, second to the last.
Oh, the the screen was blocking. The Teams was blocking. Okay, so oh yeah. So you go to developer settings, and right here there's the personal access tokens, and you can just generate a new token. Enter your password there, and once you've generated the token, you can actually just copy the token and go to Android Studio. Sorry, this is wrong. This is the app. You can go to Android Studio, paste the token, and actually add your account. So you've added your account here. Now you want to initialize your repository. So you're going to go to the terminal, and I'll show you an easy way to just put your project on GitHub. So just make a new repository. I'll name this demo app. Okay, so choose this private because I don't want anyone to see it. So create repository. Okay, so once you've created a repository, it's going to look show you this page. If you haven't initialized your project yet, you can just go ahead and use git init to initialize your project. And I've already initialized it, but it reinitialized it here. And then you're going to just add it to your remote repository right here. So you can just copy this line, and then you can just execute it here. Remote origin. Okay, so I've already done this, but if you were to do it again, it's going to remote origin. Okay. Remote, okay. Because I've already actually made another repository. So that was just the demo. But let's just go to the other repository. So this is the repository that I made before. Okay, so it should just connect to your remote repository, and with that, you can use the git commands. So you can commit, but I've already committed, and you can also once you commit, made any actual commits, you can actually just push right here to your remote repository. So since I don't have any commits, it's not showing anything, but you just push right there. And once you've pushed, it's going to show up here in your GitHub. So that is how you push your project to GitHub. And with that, I think the device is already loaded. Okay, so you can see I've already tested a few tests. So this is the test on Petronas Twin Towers, and it's predicted correctly. It even predicted a model of the KLCC Twin Towers. Okay, so let's try another one. I've already downloaded a few pictures to test, but if you don't have any pictures downloaded in your virtual device, you can just download like any other device. So you just go to home and you can just download in Google Chrome. But I've already downloaded a few images, so I'm just going to show you straight up. So this is Angkor Wat. Let's see if it can guess. This is supposed to be Angkor Wat. Okay, so it's the model isn't actually it hasn't been trained with a lot of pictures, so that's why it can't really recognize too many angles. So this is actually Angkor Wat, but in this case it predicted wrongly. But yeah, this is just the pre-trained model. If you like, you can actually just make your own model, convert it to TF-Lite, and just feed it the exact same way. So if it's about the accuracy of the model, it's no problem. So that is Angkor Wat, supposedly. And the next one, okay, Great Wall of China. Maybe it's going to recognize Great Wall of China. Okay, maybe not. It's the model is just I think needs more work because it's not trained on that many angles and pictures. So yeah, but as you can see, it works perfectly fine, and it can make predictions, it can save, and that is the finished product. Ta-da! Okay, so congratulations, you have finished the 6-session workshop for the GSC app workshop. And with that, I will pass this session to my tech lead, Maral, to explain more about the briefing for the competition that we're having to make a model yourself, to make a project yourself. So to you, Maral.
Okay, thank you, Ayn. Thank you, Shin, for today. So actually, before I start, let's have a 2 minutes break, and then I'll start with giving the briefing for our competition. Just 2 minutes. I start at 9. All right, 2 minutes up. Let's begin. Everyone can see my screen and hear my voice. Hello? Anyone can hear me?
Yeah, can hear you.
Okay, I thought I'm disconnected. Okay, so I did briefing 2 weeks ago so about competition. However, this is the finalized and this is the last thing that we came up with, and you guys need to follow the instructions as I'm explaining. So the theme of this competition is diary. So that means you have to make your own app diary. So there are two options you can select between these two. So either you will need to modify the current project that we build up during all these 6 sessions by improving the UI or by improving the actually we eliminated that part, improving the coding style, because that is actually kind of hard to assess. So not this one. And then if you want to use any new tools from Firebase, let's say you want to integrate Firebase Firestore instead of real-time database that we use, it's quite the same concept, however, very few changes in its few changes. Or you want to use any new APIs, let's say that you want to add weather prediction, and then you can use APIs for doing weather prediction if you like to. And or you can add new functionalities to the app. So either it can be one functionality up to 3 functionalities, however you think you can come up with. So the second option is that, so you choose either between these, okay, not both of them, one of them. You can make your own diary app. So the theme has to follow. The original idea should be you logging in to an app and you make your own diary. So this one the design has to be completely different from what we did. Even you have to design your own logo. However, for the functionality, since you are building from scratch, from zero, so you're not modifying any app, so you can come up with the same functionalities that we did during all these 6 sessions, or fewer, or completely different. That depends on you, however you want to customize it. And then if you do want to actually implement a database, which I think you should, use Firebase so that we know that you follow up our session and we can assess on your skills on database. So that's between these two. So the award categories, we have best UI, anyone who created a very creative user experience, and we choose best functionality or functionalities that I explained earlier, so it can be 1 up to how many you want. And the third is best creative Firebase connection. Okay, what do we mean by creative Firebase connection? So I mentioned before, so you can also use a new Firebase tool that we didn't cover up in our workshop, or you can actually if you guys recall from our 4th session that we tried to write to real-time database and and Fire Cloud storage, the storage that we saved the image there. So the connection to the Firebase, we explained before that the Firebase is NoSQL, and you can design how the hierarchy of data will look like in Firebase, or the cloud storage. So how you come up with those directories, how you connect within the code, the context of your code to Firebase, it can be different from the way that we implement it. So we use Firebase, we use the user ID from the Firebase user, and many other ways that we explained during fourth session. So it can be different. So we'll see how you come up with. And then we have also winners, or we award also our participants who actually completed all of our sessions. They were live with us at every session, and they joined our competition. So we have some awards for those participants to appreciate their participation with us. So before I'll go to actually to deadlines, I want to give some hints here. So we have this demo. So right now, when you are, if you followed everything, you should have this app already with this demo. So this is the login page. If you want to change, let's say you want to work on login page and you don't want to do sign up with Google. So we showed you guys before that there are different options that you can choose from Firebase Authentication, such as signing in with Microsoft account, or signing in with GitHub account, or LinkedIn account, or however. Or you don't even want to use the third parties, you can use your own login that has password and username. Or if you want to customize it more, that you don't want to include a login page, and that is still fine. It depends on how you would want to do it. And then it's inside the app. Once you're inside the app, you see that we have this animation. If you're working on UI, you can change the animation or put something else. So for UI, there are lots of things that you might have: the color, the arrangement of buttons, or anything. I'll mostly focus on giving you hints and ideas how to add functionalities. And then you can go and add a diary. So here you can also, for the diary, you can include a calendar. So like a calendar icon somewhere here, you design it, and then the user that is trying to add a new diary, they can select the date of their diary. And here we can see when you are actually selecting an image, the image we select from gallery. But however, in third session, we showed you that you can also use actually the phone's camera. This is selecting from gallery, you can add the camera. That is like another functionality. And then lastly, if you like to actually do the, if you like to add the TensorFlow Lite model, the pre-trained model on landmarks, the one that we just used in our project, it's for Asia only. Make sure that you select very famous images, very famous landmarks from Asia, and Asia is quite big, so they trained this model on 17,000 landmarks. And if you want to actually consider the Asia and the each landmark from each country, it's quite a lot. So the number of labels here are not that many, so this model will detect only the ones that they're very, very famous, and the image should be clear enough for the model to predict. So, however, if you guys actually join machine learning workshops, you might be able to actually improve this model. And if you want to use the TensorFlow Lite model, you can keep it. If not, you can remove it. If you want to actually work on this part, improve this part, is also okay, and you can improve this model. Or there are actually other pre-trained model on different part of the world. There is for Europe and there is for USA. So you can include those model with this model, and then you improve the prediction on this. And lastly, it's the way that the diary is being displayed. So if you are adding, let's say, the date of the diary, so you should think of a way where to place it. So here, where you want to place it to display the date. And another functionality can be if you see that here we don't have much of space to show the very long diary, and we already in our second session or the third session that we wanted to actually allow the user to add diary, we limited the length of the node to add a diary, so we could fit it here. So however, if you want to allow a longer diary, you can have this option that you click on the item or the item from recycler view that we learned last week. And then once you click, another image comes up and then it shows the full text. So you can work on that. These are all different ideas. So if you have your own idea, you can go ahead, go with it. It was just me wanted to give you guys some ideas about improving, or if you are doing your own app from scratch, you can also use these ideas. About the deadline, so the submission deadline should be from 11 DC, which means tomorrow, till 17th December. So that means you have 7 days, 6 days to submit. And we will announce the result in an award ceremony with our high caliber judges. So which I introduce you guys the judges at the end of this session. So this ceremony will happen on Sunday, 26th December at 9 p.m. to 10 p.m. So the submission format. First of all, you need to take a video of the outcome of your app. This is for just in case that we can't actually run your code, and we have some issue actually running your code. However, we want to have a reference that we can refer to and then see your final output. So make sure that you take a screenshot video, just like the ones that I was showing. This one, like a video like this, and then you upload it to a Google Drive. And today we just learned how to push our project into GitHub Repository, and we're expecting you to submit your app through GitHub Repository. However, your repository name should follow this naming format here. So GDC_UM_Android Dev Challenge your nickname. Here, put your nickname, because if you put your name, some names are pretty long, and we want to avoid lengthy text, so put your nickname. If you don't have, it's okay, you can put any name that you want. And then you need to submit these two links, the Google Drive and then the GitHub repository link to the Google form that we share it actually tomorrow. We also make an announcement here with the submission link, and here I mean on Teams on our channel, and you can refer to it. However, follow our social media platform also, you'll be updated there also. To fill up our Google form, and then you submit the link of the video and then the GitHub report. So, and then you have to complete other information that such as email contact and stuff like information like that inside our Google form. Lastly, about our judges. Oh, I forgot to make it on slideshow. Okay, firstly we have Mr. Juavet. He's software developer with more than 10 years of experience in development. He's currently working at Line based. It's a company in Thailand. He works as a technology evangelist. He's actually so active and involved in a local Firebase community in Thailand. He contributes in speaking as a speaker at conferences, and then he writes blog, and he's quite active in Firebase community in Thailand. Secondly, we have Mr. Julius. He's CTO at Zlearn, which is located in Singapore. He's also mentor for engineering leaders at Plateau in Silicon Valley, Singapore, Indonesia, India, Hong Kong, and many other regions. And he used to be a head of mobile and TV engineering at Rakuten, which you guys might heard of this company. It's a pretty big company. And outside of the work, he's a philosopher, he's a photographer, and he's a traveler. And lastly, we have Mr. Ibrahim. He's a research and development engineer at Withrox. He is actually a computer vision and deep learning engineer who works on cutting edge technology and solving real industry problems with AI solutions. And he's specialized in model optimization and deployment using in different frameworks such as TensorFlow Lite that we learned about today, PyTorch, and many more. He's also a postgraduate student at UTEM. So here was all about our judges. And last thing I wanted to talk about is our GitHub repository. So previously, this GitHub link that we shared with you, we had branches for each different session because we were going gradually to make everything in one app. However, right now, if you clone the project from master branch, everything is merged into master branch. So once you clone the project from here, you can see everything together as a package. So if you run this app, you might be able to run it, but however, you won't be able to actually use the app because we used Firebase Authentication, which only our team members they have access to. So you're not going to be able to actually use the app. So here, if you are cloning this project and you want to use this app, you need to actually connect your own Firebase project to the app and then make the necessary changes. Once, make sure actually just now we learned how to push the project into GitHub repository. Make sure that it's public so that we can access your project. If it's private, we can't see it and we can't access it and we can't assess you. That was all from what I wanted to mention about competition. However, if anyone has questions, please turn on your mic. You can ask me, or you can drop your question in the chat box. And lastly, please do our feedback form, which the link is provided in our cheat sheet. And this is the feedback form. It's anonymous, so no one knows who are you giving feedback, and we really appreciate it if you do. For simplicity, I will also paste it in our chat box here. If there is any question, we can answer your question. It's 9:19. That was all for today. So if you guys have any question, you can go ahead and ask. And I know that some of you are actually watching our recorded videos, and then you might face some problem following us through. If you have a question and you have problem, don't forget that you can always ask me in a private message on Teams, and I hope that I can help you. So I try to reply to you guys if you have any problem. Or one thing, lastly, this is our last session. I would like to invite everyone who actually likes to turn on your camera, and I want to take a picture. Oh yeah, about the competition, actually, I forgot to mention that it's open to everyone, not only who actually participated in our workshop. So any of your friends who you think would be interested doing this challenge, please introduce to them. And it's open to people from any university, but only in Malaysia, because later on when we want to provide their gifts, so we're not going to be able to provide the gift who are living outside of Malaysia. So yeah, please recommend to anyone that you think they would want to participate. Can I have some of you opening your camera, especially from app team, so we can take a picture and end our session?
Ini Bok. Tengok file sana.
Okay, cool. Any of the participants? Maybe we wait for some seconds if anyone would like. Okay, app team, do our sign GDSC, and I'll take the picture. 1, 2. Actually, I didn't say 3. I said it one more time. One, 2, 3. Okay. Thank you, everyone.
Thank
Have
you.
a good night.
Thank you everyone to join.
Bye.
Thank you.
Thank you. Thank you for joining us. Bye.